not the device. Okay. So finally, chapter 4. And chapter 4 deals with integration. So what have we studied so far? We studied limits. We studied derivatives and applications of differentiation. So these are the major topics so far, right? So now we want to be able to or learn the process of getting the derivative of a function. So given the derivative, can I construct or determine the function? An example, let's say I have the velocity formula. Can I, from the velocity, obtain the distance function s of t or s of x? Since I put x here, I have to have the same variable. So if this is the velocity, is there a way of determining the distance formula? An expression or a function that is the distance. So this is what we're going to work on initially in chapter 4, on 4.1. I am not going to use the symbol that they use just yet. I just want to explain something called, this process going from the derivative to the function is called against differentiation. So for example, and there are certain rules. Let's suppose I am told that f prime of x is, let's say, x to the 4th power. Can I determine the function? In parentheses, I will write, or let me write it anyway. So find the function or family of functions, I'll explain in a moment, whose derivative is x to the 4th, as an example. Yes. And here's how I do it. I increase the power by 1, and I divide by that number. And I will also, because I'm also interested in the family of functions, I'm going to say plus a constant c, which is any real number. Any you can think of. So now I have to convince you, because I haven't convinced you yet, that this function, f of x, if I differentiate it, I get that. I will. So if I have x to the 5th divided by 5 plus a constant prime, I know I have to bring the power in front, subtract 1 from the power. The constant prime is 0. I will simplify these two, get 1. So the answer is x to the 4th as expected. So then what is the rule behind it? So here's the rule. That's our first rule. Any questions so far? Okay, so our first rule. If I want to determine the antiderivative of x to the nth power, that will be x to n plus 1st divided by n plus 1st, of course, plus a constant c. I'm sorry I got into that. So that's our first rule, or the power rule if you want. Now, what if I want to determine the antiderivative of natural log of the absolute value of x? I already jumped ahead. I wanted to say 1 over x. And now you know the answer. I jumped ahead in my head, and I wrote the answer first. Sorry about that. So of 1 over x, now you don't have to say anything, because I'll give you the answer. So natural log of the absolute value of x plus a constant c. How come it's the absolute value? Remember, a long time ago, maybe 2 weeks ago, we had this prime, and we concluded that the answer is 1 over x, of course, for any x except 0. And I said this will come back to us, and here it is. The antiderivative of 1 over x is natural log of the absolute value of x plus a constant c. I was going to ask you, but I started with my own answer first. Okay. Just a week ago, I think I read a note. It was a sign somewhere, but I read it on the internet. It said, if you cannot, life is too short. If you cannot laugh at yourself, it's okay. Call me and I will. So you don't have to call me. I laugh at myself all the time. But you can call me anytime, though. Okay, so now I would like us to practice, of course, what is the antiderivative of e to the x. What do you think will that be? The antiderivative of 1 over x is that. The antiderivative of x to the n power is that. The antiderivative e to the x, what will that be? And of course, this is the nicest and the easiest, always.
E to the x plus c.
E to the x plus c, indeed. Good. So I have the book ready. I'm going to share my screen with you because I know I have the book ready. I already potentially, where is it? Here it is. Okay. Good. They are using the symbol. Okay, let's use the symbol because then it will be difficult. We can make stuff up, but let's use the symbol. Okay. So this uses a notation that I wanted to introduce later, but your book forces me to do that. So all these are called indefinite integrals. So they are the antiderivative. In other words, undo the process of differentiation. That's what we're doing. But the notation is called the indefinite integral. So what is it? I really didn't want to do this in this order. With my other calculus class, the 191, I don't do it in this order, but that's fine. So this is the letter S stretched. So it's the sum, basically, and I'll explain in the next section why we're using this notation, of e to the x dx. Again, I have to explain all this. And I can't explain it right now, so I just have to show you how the way the book does it. And I will clarify what this means. So this is the integral, or the antiderivative of function e to the x. But I also need dx. Why? I'll have to explain. Not at this point. So then the answer would be e to the x plus a constant c. So instead of saying antiderivative of e to the x, I use the integral symbol, the indefinite integral symbol, and it has to have dx. Why? Because this, if you remember, is the differential of the function. It's not the derivative of the function, it's the differential of the function. Okay, for all the other ones, the integral from 1 over x dx, this is the dy of the function, is, as we discussed, a natural log of absolute value of x plus a constant c. And the first one, the integral, the indefinite integral of x to the n dx is x to n plus 1 over n plus 1 plus a constant c. What we are doing here will become very clear soon. Promise. Okay. Why we need these two and why we need the symbol, I will explain. This will be very clear. Okay, so let's share and let's work on any of these problems. Before that, I can also present, and I should, 2 more rules or properties if you want. So I'm going to stop sharing for just 1 more second. So properties of the indefinite integral. Okay, number 1, So the indefinite integral from of a function plus another function, 2 or more, it doesn't matter, right, is the same with the integral from f of x, if you want, plus the integral from g of x dx. That's one property. Of course, if I have minus here, I also have minus here. Another property will be the integral from a constant times a function dx, like with the limits, like with the derivative, with the integration, the same thing. This is c, the integral from f of x dx. Okay, so now let's select and practice the indefinite integral. Okay, I will choose first. I like to start with 5, the integral from x to 1/4 dx. So remember, we are integrating, we are not differentiating. So according to the rule, the power rule for integration, I will have to find, I will have to write x to 1/4 plus 1 over 1/4 plus 1 plus a constant c. Again, what is this constant? This comes into play only for indefinite integrals. Is required. Why? Because I can have infinitely many functions with the same derivative, x to 1/4. And then I have to simplify. So 1/4 plus 1 is 5/4, and I have to flip 5/4. So this is 4/5, and x to 5/4 plus a constant c. The indefinite integral can be checked. Here's how. So I claim that the integral from x to 1/4 dx is the same with 4/5 times x to 5/4 plus a constant c. I want to check by differentiation. So remember, when we solve a radical equation, we want to undo this. That's why we square both sides. The same thing here. The differentiation will undo the integration. So when I differentiate an integral, I just get the function. So the left-hand side, when I differentiate an integral, I just get the function. Let's see what we get on the other side when we differentiate. We bring down 5/4, so 4/5 times 5/4 will be 1. I subtract 1 from the power, so I get 1/4. And when I differentiate c, I get 0. These two will go away, and I get x to 1/4 equals x to 1/4. So indefinite integrals can be easily checked. How? By differentiating both sides. I have to get the same thing. So let me write this here on page 4. Notes. Number 1, differentiation. And integration are inverse operations. Like e to the x and natural log x. Like the square root of x and x squared. Like so on and so forth. Number 2, indefinite integrals can be checked by integration, of course, by differentiation. What would I do without my whiteout? I hope we never run out. Okay, good. So now back to sharing, and you select whatever you want.
Can we do number 16?
16. Anyone? Any other?
And 23.
And 23. Anyone else? Or let's do these two first. Good. So number 16, I see it. Number 16 is the integral from the cube root of x squared dx. And 23, where are you, 23? Right here. Good. So that's the integral from -7 over the cube root of x squared dx. Perfect pick. Okay, so obviously I will try to simplify as much as possible, and I will change this into x to which power?
Negative 2/3.
Careful, it's not in the denominator, right? So just 2/3. Perfect.
Oh, okay.
If it were in the denominator, yes, I would have said minus. Good, excellent. So I apply the same procedure. It's the power rule, x to 2/3 plus 1 over the exact same number plus a constant c. And now I have to clean it up because 2/3 plus 1 is 5/3. And I have to flip 5/3 into 3/5. X to 5/3 plus a constant c. And this is the answer. And if you differentiate this side, it's guaranteed you will get the same answer.